All right, hello everyone, this is Mr. Crozier. I'm going to go through some trig equations for you here. Number 14, it says tangent of x plus root 3 is 0. Well, I'm going to simplify it down to just one single trig equation. And now I'm going to look on the unit circle for places where tangent is negative root 3. Well, the first thing you need about tangent is the tangent angle of root 3 is when we have the tall skinny triangle of 60 degrees right here. So if I'm looking for tangents of root 3, well, that would be this one, that's 60 degree, and that's 60 degree. At this point, both of them are negative root 3. So the question is, well, what are those angles? Well, it is x, this is 2 pi over 3, plus infinite loops around the circle. That's what that n stands for, any number you want of loops. And this one would be 5 pi over 3 plus 2 pi n here. Again, this is a period of tangent here, or this angle goes all the way around here. But the thing about tangent is the period is just pi, so these angles are exactly, if I were to draw this, they are exactly evenly spaced out for 180 degrees, right? So what I can do is I can transform these two equations into one simple equation of x is equal to 2 pi over 3 plus pi n. And this equation right here accounts for this angle. Then I go down 180, accounts for this one, add on another 180. And writing these two equations this way simplifies it into one nice, neat expression that shows all the angles. Always try to simplify it. Write them out first and then try and simplify. 16. Well, I'm going to subtract that over there and subtract that over here. I think you will see I have 2 sine of x is equal to negative 1. Divide by 2. Well, then once we get to this point, we always draw a picture, and it's going to be this small triangle right here, right? This small triangle is where I have a negative 1/2. And those angles are x is equal to 7 pi over 6 plus 2 pi n, and x is equal to 11 pi over 6 plus 2 pi n. Well, these will not be simplified. Because if you notice, this distance right here between these two angles is not the same as this distance. So they're not evenly spaced out, so there's not an easier way to write this. Number 18. I have the cotangent here. If I put this over here, I have cotangent squared of x is equal to 1/3. And now I'm going to solve this equation by taking the square root. And after I do that, I will have 1 over root 3 plus or minus. And now see if you can write the tangent for that and draw the pictures. So, all right, sorry for the delay. Hopefully you are able to say, look, cotangent is really tangent in disguise, but the tangent would be plus or minus root 3. So then now that I have that, where are these angles? Well, these angles are here and there and there and there. So it's all of those. It's all the positives and negatives. So if I were to do this, my answers would be, I'm going to start at this angle here, which is pi over 3 plus pi n, and that will take me from there to there. But now I'm going to use a different color, and I'm going to go from this angle to that angle, and from that angle to that angle would be, let's see here, I'm starting at 2 pi over 3 plus pi n. All right, so number 20. Number 20, let's go ahead and solve this one. It would be move this over here, and it would be negative 4 sine squared x is equal to negative 2. Divide by negative 4, wouldn't that just be 1/2? take the square root. Sine of x is equal to plus or minus 1 over root 2, which is really just plus or minus root 2 over 2. Now, where are these angles? Well, where is sine this? Well, that is exactly in the middle at 45 degrees. Then exactly. That's that 45 triangle. So that's where sine is all of those. So it's all of these. Watch this neat way to write this. I'm going to start here at pi over 4. And then watch each one of these turns. They are a quarter turn. So every turn here is 90 degrees. So I can start here and add on 90 degrees every time. And that will account for all the answers. All right, last problem. Number 22. I have this problem, and the way I see it as a math person is I have an a term multiplied by a b term equal to 0. Or an a expression, a b expression multiplied to get there. So one of them has to be 0. So this one could be 0, or this one could be 0. So the basics are, this is a two-part problem. There is a left part that you have to do, and there's a right part that you have to do. There's no way to escape that. It's a double problem. Well, this one, if I solve this, what would that be? Sine squared of x is equal to 1/2. Well, hey, I just got done doing this problem, right? I just got done doing this problem, and I have the solutions right there. There's all of those solutions. So I'm not going to redo that one. It started at pi over 4, and then I put on a bunch of 90-degree turns. And what is this one? Well, that is tangent squared x is equal to 3. Tangent of x is equal to plus or minus root 3. And I believe we've already done that problem. I believe that problem is right here. So we just have these answers right here. We're going to start at pi over 3 and add on 180 degrees. And we're going to start at 2 pi over 3 and add on terms like that. All right, I hope this helps with your homework. If you have any questions, see me in class.